Hey everybody. This unit we've been doing a lot of work with linear equations. We've been writing them in different forms. We've been graphing them a lot. Tonight we're going to look at one specific kind of special case when we have two different linear equations that give us perpendicular lines. So for our first example here, we have two equations to start off with that we're going to graph. We have y equals 2/5 x minus 3 and y equals negative 5 over 2x plus 5. So let's just graph these. For our first one, we'll start at the y-intercept, which is negative 3, and we'll use the slope. The slope is 2 over 5, so I'm going to go up 2 and to the right 5. So we got a point right there. And we can also go down 2 and to the left 5. And see, now we have our points in a nice straight line. All right, and let's go ahead and we will graph that line. I'm going to cheat here, use my straight line tool. And we'll put a couple arrows on to show that this line continues into infinity. Now, let's graph our second line. Let's do this in a different color. We'll start at 5, and my slope is negative 5 over 2. So we'll go down 5 and to the right 2, down 5 and to the right 2, and I can't go down anymore. I also can't really go up anymore. So now we will just graph our line again. So we'll graph a line. We'll try to get as straight as possible, going through these points. And notice how these lines intersect, right? They intersect at a 90-degree angle. And that's what perpendicular lines are. Perpendicular lines intersect. That means they meet each other at a 90-degree angle, or a right angle is another word for that. Let's take a look at another pair of lines. Let's see if these two are perpendicular. We have y equals negative 2x, so we know our y-intercept is 0, because it doesn't say plus or minus anything, and we have our slope of negative 2. So we'll go down 2 and to the right 1. That's negative 2 over 1, remember. And we can also go up and to the left. Make sure we got a nice, pretty straight line. And we will draw that line, passing through all of the points, and draw our arrows. Okay? Now we'll graph our second line here, y equals 1/2 x minus 3. We start at negative 3, up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, and go the opposite direction. We don't need to graph all these points, but the more points we graph, the better our line is going to look. The more straight it's going to look, the more accurate it will be. And we'll draw our arrows. Now, once again, notice how our lines are intersecting. We have a perfect 90-degree angle right here. We draw a little box to show a right angle. So once again, we have two lines intersecting at a 90-degree angle. The big question we have to ask ourselves is, why are these lines perpendicular? Why do they meet at a 90-degree angle? It all has to do with the slopes. Remember how parallel lines always have equal slopes? In perpendicular lines, the slopes are also related. If we look at our first two slopes here, from our first graph, 2 over 5 and negative 5 over 2, we notice something they have in common, the 2 and the 5. In this case, the 2 is in the numerator and the 5 is in the denominator. In this case, the 5 is in the numerator and the 2 is in the denominator. So really, we just flipped this. We took the reciprocal, and we have it right here, except this one is positive and this one is negative. So really what we have here is we call it the opposite reciprocal. We flip the numerator and denominator, change the sign. We have the same thing over here in our second one, except notice that we have negative 2 and 1/2. But if we think about this as negative 2 over 1, we notice that we have the exact same thing. We started with negative 2 over 1. We now have positive 1 over 2. And that brings us to our big rule about perpendicular lines. Perpendicular lines on the coordinate plane always have slopes that are opposite reciprocals. Reciprocal means we flip the numerator and denominator. Opposite means we change the sign. So, for instance, if we have a slope that is a over b, the reciprocal of that, the opposite reciprocal of that, will be negative b over a, right? And that can go both ways. If we have negative b over a as our slope, the line that will be perpendicular to that will be positive a over b. So we can use that to find the slope of any line that's perpendicular to another line. So for these examples below, I want to know what is the slope of a line that is perpendicular to each line below. That means if I graphed this, what would the slope of a line that intersects this line at a 90-degree angle have to be? So if we look at the slope of this line, right, we know the slope is 3, and we can think of that as 3 over 1. The slope of a line perpendicular to that, we would need the opposite reciprocal. So 3 over 1 would become 1 over 3, and we have to make it the opposite of that, so we make it negative. So negative 1 over 3 is the answer. That's the slope of the line that's going to be perpendicular to example A there. In example B, we're going to do the same thing. Take the reciprocal and change the sign, the opposite reciprocal. So negative 3 over 2 becomes positive 2 over 3. Example C, we're going to do the same thing. We'll flip it, take the reciprocal. 1 over 6 becomes 6 over 1. And we change the sign. And negative 6 over 1 is just negative 6. Example D, last one on this slide, we got negative 4 is the slope, negative 4 over 1. So that means we're going to flip that, and we're going to get positive 1 over 4. Flip it, change the sign, opposite reciprocal. So that's not too bad, right? Not a lot of math. All we have to do is find the opposite reciprocal for each slope. This knowledge also comes in handy when we want to identify whether lines are perpendicular or not. We just have to check the slopes and see if they are opposite reciprocals. So for example, E here, our first slope is negative 1. I want to know if these two lines are perpendicular. I know my second slope is positive 1, and I want to see are these opposite reciprocals. So let's write these both as fractions. I think that might help us see it a little better. Now in this case, we have negative 1 over 1 and 1 over 1. Now if I take the opposite reciprocal of this, that means I'm going to flip the 1's, and I'm going to change the sign. So it'll become positive 1 over 1, which is exactly what we have here. So the answer here is yes. These lines are perpendicular because the slopes are opposite reciprocals. Now let's look at example F here. I have m equals negative 1/3, and I have m equals negative 3, and we can think about that as negative 3 over 1. Now here, negative 1/3 to negative 3 over 1, I am taking the reciprocal, but the signs don't change, right? This isn't the opposite reciprocal, this is just the regular reciprocal. So because we have negative 1 over 3 and negative 3 over 1, these cannot be perpendicular. Reciprocals, but not opposite reciprocals. All right, that's our last example for tonight. You can go ahead and finish up your notes, submit them through Canvas, and I will see you all tomorrow. Have a good night.